Hi guys, welcome. This simple lesson is on arc measures of circles, and let's begin. Okay, so go over these are a few definitions right here. So given this circle right here, if it comes out from the center of a circle, this is called the central angle right there. All right, and then so right here, given a central angle right here, this arc from this part of the circle is called a minor arc, and then the other part of the other side of the circle is called a major arc. Whoops, shouldn't have taken that out. Anyways, let's see if I can get that back in there. Okay. Uh, okay, and then if it goes halfway around the circle, then it's called a semicircle. Okay, so there's another semicircle down underneath here. It's half the circle. It goes right through the center, right through the diameter, so it's called a semicircle. Okay, arc measures. The measure of a minor arc is the measure of its central angle. Here's a picture. Okay, if this central angle is 85 degrees, then this minor arc right here is also 85 degrees. Okay, here's another definition. The measure of a major arc is 360 degrees minus, that's a minus sign, the related minor arc. So let's use that same circle right there, you guys. If this is 85 degrees, then this side's going to be 360 minus 85, so this arc out here is 275 degrees. Okay, that's all that says right there. Semicircles are 180. All right, so here's a diameter going through, and it makes two semicircles, so 180 on both sides. And you guys probably know that a circle is 360, so 180 on top, 180 on bottom, or if it was going through, going through that way, it would make 180. Just if it goes through the diameter, it's 180. Okay, arc addition postulate. Okay, you've heard of segment addition postulate, and you've heard of angle addition postulate. Well, it's the same thing. Arc addition postulate just means that this arc right here, arc AB, plus this arc right here, arc BC, equals the entire arc, arc ABC. And I like to say piece plus piece equals the whole piece. Okay, just like angle addition postulate and segment addition postulate. Okay. Let's see. So let's try some of these, you guys. Now, in your book, in your textbook, it's probably going to give you a little circle with a dot in it, so you don't think it's the letter O or the number 0. So it means circle, you guys. So find the measure of each arc in circle C, and it's always named by the center, the letter in the center. So a circle is named by the where the center is. Okay. So and it says AB is a diameter. So okay. So and they only gave us this 135. Well, they did tell me that that's a diameter, and diameters give me semicircles are 180. So if this is 135, this piece is going to be the rest of 180 because it's going to be 180 all the way from this whole diameter right there. So 180 minus 135 will tell me this little dude right here is 45. Okay, so that's a central angle. If that's 45, this is going to be 45 right there. And if this is 135, this is going to be 135 right there. So arc DB is 135. Arc AD is that over here. That's at 45 right there. Arc DAB, start at D, go through A, all the way around to B. Okay, I know this side is 180 because it's a semicircle, and I know that this is 45, so I'm going to use my arc addition postulate. 45 plus 180 gets me 225, and then arc ADB, this last one, ADB, that's the top of the semicircle, so that's 180 also. Okay, so I think, did I get them right? I think I did. All right, okay, a couple of theorems, you guys. Let's see. Congruent circles have congruent radii. Radii is plural for radius. These circles are congruent because they both have the same radius. The radius is 5. Okay. Let's see. Arcs are congruent if they have the same measure in the same circle, or if they have the same measure in congruent circles. Okay, so arcs are congruent. Whoops, I shouldn't have done that. Are congruent if they have the same measure in the same circle or in congruent circles. All right, so let's try some of these. So tell whether arc CD and arc EF are congruent, and explain why. Okay, so here I have this circle right here, and I have arc CD right here and arc EF over here, and I know that since that's 45 degrees, it's a central angle, so this is 45 degrees, and since that's 45 degrees, then that's 45 degrees, and since they have the same measure in the same circle, then yes, they are congruent. So I can conclude that CD is congruent to EF because they have the same central angles and they have the same arc measures out there. Okay, what about this one right here? Okay, here's arc CD. Okay, and then here's arc EF out here. Okay, now if that's 110, the deception on this, you guys, is this is 110 right here. Whoops, my darn little cursor. That's 110 right there, and so this is 110 also out here. But they're not the same measure. They're not the same length because the radius is smaller in this small circle than the big circle. The circles aren't congruent. This length right here is much longer than this length. Even though they have the same degree measures, the lengths are different. So no, they're not congruent circles, so they're not congruent to each other.